Okay, let's go ahead and get started. I'd like to thank everybody who's joining us today. Today's CNCF webinar is Migrating Real-Time Communication Applications to Kubernetes at Scale, Learnings from 8x8's Experience. I'm Julius Rosenthal. I'll be moderating today's webinar. We would like to welcome our presenters today. Lance Johnson, Director of Engineering, Cloud R&D at 8x8. Michael Laws, Senior Site Reliability Engineer at 8x8, and Pankaj Gupta, Senior Director at Citrix. A few housekeeping items before we get started. During this webinar, you are not allowed to talk as an attendee. There is a Q&A box at the bottom of your screen. Please feel free to drop your questions in there, and we'll get to as many as we can by the end of the presentation. This is an official webinar of the CNCF, and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or ask questions that would be in violation of that Code of Conduct. Basically, please be respectful of all your fellow participants and presenters. Please also note that the recording and slides will be up later today on the CNCF webinar page. So with that, I'll hand it over to Lance, Michael, and Pankaj to kick off today's presentation.
Thank you, and thank you to CNCF for giving us the opportunity to share learnings of our most privileged customer, 8x8, for their journey to microservices and deploying Kubernetes at scale. As you know, 8x8 is a company who offers collaboration solutions, and which includes voice, data, and video. And they will be sharing the best practices about their journey to microservices-based application. And I also strongly recommend that please wait till end of this webinar, because Lance and Mike are going to talk about the 10 key takeaways which will influence and enlighten you that how to deploy your own Kubernetes environment, and some of the best learnings you can put this in the practice. So please stay tuned till end of the webinar, where Lance and Mike really share deep insights, and there are 10 of them. As you already know, that many of the organizations are moving to microservices-based applications. And microservices-based applications are more relevant than ever before, especially in this pandemic and also for business continuity. There are three key reasons, as you know. First is the modular application architecture, which allows you to develop individual services independently, deploy them independently, and auto-scale independently. And that actually drives the faster releases, and that's every IT organization and every developer's team and every DevOps team dream is to really deploy new releases much faster. And third is the portability. As containers and microservices are self-contained runtime, the portability across clouds are much simpler, and you will hear some of those examples when 8x8 shares their journey for portability. As you will find in this journey from 8x8, each stakeholder has a very unique needs. Platform teams is the center attention there. They are really looking for a platform governance, operational efficiency, and developer agility. We also have Mike today. He is the SRE himself, and he's going to share some of the architectural choices and best practices from application availability, observability, incident response, and some of the postmortems. And of course, the DevOps teams really look forward for a faster release cycle, and Mike and team will share that how they have increased their deployment frequency and giving a better user experience to their developers, and also helping their NetOps team to enforce a better network policy and compliance for that. When you look at the application delivery solutions, there are 5 key steps you have to consider. And these are also the 5 key steps which Citrix has built solutions for that. First is architectural flexibility. You should be able to support architecture choices from a simple 2-tier ingress to the North Star service mesh. So you can balance the benefits and the complexity, and you will hear from Mike that what architecture they started and what they learned and what they wish now, what architecture they should have selected. So there is a big reveal from Lance for that. Second criteria, when you look at your application delivery solution, you have to make sure that integrates with your choice of Kubernetes platform and also vast variety of open source tools which you are using or planning to use. Performance and scale is very, very critical because you are building microservices-based application to scale on demand. And especially when you build applications for real-time communication like voice and video, the latency matters, and latency is also additive. And proxies like Citrix CPX or Citrix ADC portfolio matters into that. The 5th criteria when you look at the solution is about having a consistent and a robust application and API security. You see, most of the customers are really protecting their north and south traffic, but communication between microservices is still remain to be protected, or a broader and better security measures are required. And 5th, which is very, very critical for any SRE, is the observability stack. So you can identify the things faster, and you will hear some of those conversations from Mike being a SRE, how observability played a very critical role in their journey for that. With that, I will like to invite Lance to share his insights, their journey, and also introduce himself.
Hi, yeah, thanks, Prankash, and thanks to the CNCF for hosting us. I'm here from 8x8, and to talk about a problem, that analogy I like to call the DevOps 3-body problem. So my name is Lance Johnson. You can reach me at these different social media interactions. I'm also here with Mike Laws. He's been in he's in our reliability. Some of our accomplishments. I think Mike's underselling himself, but
yeah, that's the one that matters to me right now.
But some of my most proud badges I have on my laptop, and my wife always jokes that when I tell her going to a conference, she's like, "Oh, you're just going to a sticker trading fair." But if you see this laptop, definitely just say hi to me. Say I saw you on a webinar, and chat me up.
I so out of that laptop too, because that's a Commodore 64 under all those stickers.
Yeah, totally. It's been there forever. I mean, I'm trapped on the same memory and CPU for 6 years now. It's hilarious. So 8x8, we're a unified communications platform. One-stop shopping. We're bigger than you probably know, but we're in many different countries. We've got close to, it's an older slide, I think we're even closer to 2,000 employees now in a myriad of countries, and we have millions of customers, business customers. But you can, you buy from us and you get a single experience that covers all your meetings, your voice, chats, and we can chat even across platforms to other systems. And the same system gives you even call center management capabilities as well. It's all in one bundle. So the 3-body problem, what is it? Well, it's it's an unsolvable mathematical problem. At least, they're getting close to it, but I think it's just statistical. It's not a true solution yet. But this is the problem that even though Newton invented calculus just to describe what he was thinking about the heavenly bodies and where the moon and everything moves and stuff, he still couldn't solve this problem. And so, so what does it mean to say a DevOps three-body problem? So the three things that are kind of pulling in the different directions. The first one is kind of, getting your service in place, putting it somewhere, right? And then launching it, getting it running, right? So there's from the mundane to the more exotic, you've got Bash shell scripts or Ansible or Chef or Kubernetes, Terraform, CloudFormation, all that kind of stuff. So there's the challenge of getting it there. The other thing pulling on you is, making sure your customers are connected to the right one. If in an HA in a global scenario, you're deployed all over the place, right? So, but is the right customer getting to the right service at the right time, right? So DNS, you've got, proxies, you've got geo-aware DNS, you got latency-based DNS, all kinds of stuff to try and get the end user to the right endpoint. And then lastly, 8x8's a 25-year-old company. We all have legacy systems, and one of the best comments I ever heard a long time ago was, yeah, legacy, the stuff that makes money. We're on the same journey to kind of refresh that stuff and get new technology in there, and that comes with its personality of the persistence that's been there for a while, of files and databases and all that stuff. So all three of these kind of pull at the same time, and they pull with varying degrees of who's screaming the loudest. So this is kind of the triangle that all kind of DevOps people are stuck in trying to solve. And so, how did 8x8 approach this problem? Well, I think we tried to do it with a little bit of style. I don't know. You got to laugh at yourself, but over the few years we've learned a lot. I think we started 1.8 and now we're up to 1.16 in Kubernetes. But even though we've had a lot of accomplishments, I still feel like sometimes we're pretending to ride a horse as opposed to actually riding a horse. So, the fundamentals of how we approach all of our problems, I throw this slide into every single presentation I do. It drives my boss crazy. I could be talking to finance about some dumb, mundane thing, trying to justify some software, and I'll throw this slide in there and he'll be like, what are you doing? But, it's pretty, I think, well known in the industry. These are the kind of things you want to base all of your decisions on, and how you approach all the different problems. You want to make things safe. You want to be able to, when you make a change, make sure you can test it, make sure it works. You have to do everything with an automation, and you really want to do the exact same automation everywhere, kind of separate the identity, the data specific details of the environment from the actual mechanism of putting it there, so that you can use the same mechanism everywhere. And we want to do everything, collaboratively, like let everything in kind of GitOps and letting people see it, letting people understand, even though they aren't part of the group. If they can be part of a merge request, then they can learn exactly what you're doing and stuff. And we want to, enable teams to be completely autonomous so that they can move at their own speed, whether it's from the development teams or even the operations teams. So microservices, we're on the same journey that everyone else is. You take a large monolith, you've got a lot of software running, all the stuff that's making money, but you want to make it better. So you start carving it out in smaller pieces. Which ones and why did we decide to do this? It's this same thing. You want to divide and conquer, like Pankaj mentioned early on. You want to make it easier for individual teams to go faster. You want to refresh the technology. And so, how did we approach that? I mean, this is a screenshot actually from one of our development environments, and each one of those octagons is an actual service. So it could be a team, of few developers to 10 developers, however many. So it's each one of those could represent an entire team. And so, one of the things we did was when we were starting our journey with Kubernetes, we chose to start with actually stateless applications so that it was easier to kind of, while we learned and got used to the how Kubernetes runs and stuff like that, and so we matured it into a more of a production environment, we did it that way. And we started with a framework that we provided to our development teams. And so that scaffolded up a lot of stuff for them automatically. And then on top of that, they built some shared services that are common to all of the tools we need. But, you know, like RBAC, not every team needs to learn how to do RBAC every single time for every app. It's part of our framework. So that's kind of the approach we took. We did as much as we could so that the teams, individual teams, could just focus on what is the exact value that they're trying to provide. Our design goals, it's the traditional Kubernetes mantra, I would say. We wanted everything to be uniform no matter where they were. So once you've lifted your development teams up into the logical state definition that is Kubernetes, then all bets are off. It just frees them from it. They don't need to know. They don't even care, actually, as long as the process works and it can get to its dependencies and you get the right people to it. Then they don't care if it's on-prem or in varying different clouds. And it actually gives you the capability to be multi-cloud, really. You know, a lot of people talk about that, but my elevator pitch for it is it takes all the best stuff from public clouds and gives you the ability to put it anywhere you want. So it's uniform, it's the exact same deployment. We use the service discovery within Kubernetes, even though we have as part of our framework. Obviously, you know, it has the high availability and the automatic recovery. We did push very hard to be as native to Kubernetes as possible. We didn't want to, the framework doesn't create our own custom objects or too many things like that, because we also wanted to use as many of the public charts as possible. And so that part of that framework, we actually scaffold up charts. So we use Helm and to manage that stuff. It's a funny story that the guy that we worked with doing the framework or defining the framework, you know, we were 6 months into it and there was a bunch of clusters starting to come up, and he woke up in the middle of the night and he's like, oh, how do we know how are we going to recover an entire cluster? Like, how do we know which services it employed where and stuff like that? So that's when we really embraced Helm and started working that way. And we even built a service to kind of maintain the history of the values and the charts around and what clusters they're targeted to. More of the same, less orthogonal. If you don't like the orthogonal look, you know, we spread our clusters across availability zones. We have multiple zones for the different regions, and then we put cloud load balancers up in front of that so that we could progress our clusters easier. We could, you know, introduce more regions and whatnot. So what does our hybrid environment look like at this point? So like I said, we started out with one cluster and very quickly it was like, okay, we need more than that. You know, we're still learning the cluster, plus we're expanding our usage and going to different regions. So we eventually put a load balancer in front of it. But then that, you know, each stage of our promotional life cycle started to become the same thing and get bigger and bigger and bigger anyway. So eventually US became multiple load balancers in front of multiple regions, and this allowed us to kind of insulate ourselves from the actual implementation of the cluster. We could, you know, upgrade the cluster by just putting another one right next to it instead of trying to do an in-place upgrade. We could also start playing around with managed services, so EKS, and, you know, we've pulled that same pattern back on-prem with the Citrix products, because they gave us the exact same kind of experience we had when we learned in the cloud. We started kind of in a cloud provider originally to kind of erase any, or not have to deal with any environmental personalities that had grown up, you know, as a natural physical environment does. It was all uniform and 100% of it was automatable in the beginning. So that's why we started in the cloud and kind of came back. But now that we've come back, you know, lifting the development and the workflow definitions into Kubernetes, we didn't want that to change once we started to come back. And Citrix really helped us with that, because they were probably the best that maintained that feeling within Kubernetes. Like, it's still just a few annotations and we can manipulate the cloud. So with that, we'll talk about that on-prem environment, and I'll hand it over to Mike.
All right. Thank you, Lance. And thanks everyone for attending here. I'll try to make this pretty brief here, but to kind of expand on what Lance was saying regarding the architecture and bringing this back on-prem, we made the decision early on. We said, we're going with Kubernetes. You know, it solves a lot of problems for us in terms of kind of the life cycle and automation and those sorts of issues with our application environment. And so what we wanted to do was bring that back on-prem for various reasons. For example, like Lance mentioned early on, we have databases, other applications, other services that haven't necessarily been re-architected to work within Kubernetes. So those still live in our data centers. So we wanted to have some of these Kubernetes workloads be closer to those services. So, and there's a lot of other reasons as well. You know, this webinar is really has this real-time component to it as well. So, you know, as you know, 8x8, voice, video, those are all real-time-ish applications. And so for us, every millisecond matters. So with the voice path, we want to make sure that we're not introducing latencies where we don't need to, things like that. And today, our communication with service providers and the you know, the voice side of things is still hosted out of our data centers. And so we want to keep some of those real-time components close to our Kubernetes environment as well. But having made the decision for Kubernetes, we realized, and I'll use the word I think Lance didn't want to use, which is baggage. We didn't want to bring a lot of baggage into our Kubernetes infrastructure, which is why we said, let's put this in the cloud first. Let's kind of bring this up clean, the way we think it should be. And then we're taking that learning and bringing it back into our data centers. So we have, knowing that we're going to support Kubernetes, we said, let's take a second look at what we're doing in the data centers. We've been around for almost 30 years, have been providing services of you know, varying levels of service, but, you know, different, 8x8's gone through some changes over the years, but we basically in the data center have almost 30 years of baggage, right? That we really needed to kind of take a second look at, especially if we're going to operate Kubernetes at scale and with any sort of promise of reliability. So with that Kubernetes implementation came kind of a whole redesign of what we're doing in the data center. And it's really kind of articulated here in this diagram, more or less. We knew we still wanted to support some of our kind of legacy monolithic applications, the stuff that's not operating in Kubernetes today. But we wanted to do that in a more kind of structured environment where we could provide kind of a zone isolation, so we can reliably say, hey, you know, database node A lives in this part of the network and it's physically separated from database node B, which is in this other piece of the network. And so if there were a failure, you don't have any possibility of a failure in zone A affecting zone B, which is really important when you go to operate Kubernetes in a production environment. So what we ended up doing was what you see here, which is a 3-zone architecture, and every zone has its own dedicated resources, from storage to networking to load balancing, which is our Citrix ADCs. We're using the VPX, by the way, which is a virtual appliance, super flexible, and it works perfectly for us. I'll get into that here in a minute. And we're also using, like I mentioned here on the left side of the slide, we're using Calico as our network plugin layer. And that's really, that decision was, part of it was that latency perspective. You know, we wanted something that was very close to the network. And when I say close to the network, meaning we weren't adding additional layers and headers and wrappers around packets and things like that. We wanted this to be as raw as possible on our network, so that it minimizes latency. And I'll do a blog post at some point in the future here that kind of digs into that aspect of it a little bit more. But Calico is what we ended up using, and to make that really SING in our network, we deployed route reflectors in every zone as well. And that's our interface into the network. You know, being in that SRE position, you know, we're at that, you know, to Lance's whole point here is, you know, you're in that intersection of, you know, you've got these different forces kind of pulling on you and whatnot. And one of those is, you know, we have compliance and we have standardization. We have all these things, especially in our network infrastructure, where we want to make sure that we're controlling change and things like that. But when you kind of weigh that against, you know, speed of deploying these applications, you know, how quickly can you iterate a change? How quickly can you deploy a change into the infrastructure? If you're making network changes and kind of fighting with change management and all that sort of stuff, obviously that can slow things down. It gets really difficult to manage. And so when we designed this architecture, we wanted to make sure that we had the ability for kind of the networking team to work autonomously, but allow the Kubernetes and the application side of things to really be able to interact with the network safely and without any kind of, like I said, manual intervention or anything like that. Route reflectors, Citrix ADC, and of course Kubernetes, all of that makes all this possible. So we're really kind of pleased with how this all came together. And I'll talk really quick about kind of what each one of these zones is. Perfect, you read my mind here. But talk really quick about what each one of these zones consists of. It's, like I mentioned, separate zone storage, and that plays perfectly with Kubernetes persistent volumes. So we deploy, for example, a application with any kind of persistence, a database, something like that. Through the Kubernetes API, it can request storage. That storage is co-located within the same zone. And so if we need to, when we need to distribute that across zones for that fault isolation, for that failure domain kind of separation, this architecture and Kubernetes support with the persistent volumes makes that all possible. Each zone has its own dedicated route reflectors. So I mentioned BGP and Calico. What we do in this scenario is when we deploy a workload into Kubernetes, you've got to get traffic into that workload, into those pods. And traditionally that's through a service or an ingress or something of that sort. And there's also the notion, I won't get into too much in this discussion, about direct to pod, or maybe some of those DSR use cases where we may want traffic to actually get directly to a pod. And that's another one of those latency sort of optimizations that I'll talk about at a later date. But BGP kind of helps us do that, where what we can say is deploy an application, and let's say we want to earmark a specific class of pods to actually have a publicly addressable IP directly on the pod, for example. That sort of stuff is possible through Calico, through BGP, and through this architecture. So we'll actually advertise IPs straight out over our backbone, straight to the internet. And so that's a very, I call it like the what do you call it, a CDN sort of model, right? You know, in terms of kind of how this is architected. That's really the minority of things that we're doing. The vast majority of what we're doing in Kubernetes is kind of the traditional, through a proxy of some sort, through a service or an ingress, and that's where the ADC really comes in, and that provides a lot of benefits. A lot of that stuff Lance already talked about, but when we deploy an application, we're not doing something unique and different and special in the data center to make those applications work. You know, it's the same sort of look and feel and experience that we're getting from our cloud side. We've actually, through Citrix, been able to translate that into the data center. So actually, when we first stood this up, Lance and I were both kind of grinning to ourselves the whole time, because we were really happy with how easy it was to bring this up and then just literally deploy our applications with little to no change. You know, it was a few a few annotations that we had to change and things like that, but it was all something that we just plugged right into our deployment platform, and everything just worked like a champ. So then the ADCs, we're using them in sort of a unique fashion. I want to touch on this really quick before I hand this back to you, Lance, but In our data centers, I mentioned, we've got a lot of history in the data centers, and we've got a lot of, how do I say this, sort of heavyweight HA, where, for example, you may have 2 load balancers, they're passing state around, they're this kind of single entity, and if anything goes wrong with that, that state between these things, catastrophic problems happen, and this is a problem I've seen time and time again over the years, and what we wanted to do a little bit differently here was allow us to still get traffic with some session persistence to each one of these ADCs that are spread across zones, but also give us the ability to scale these ADCs horizontally without having to worry about, oh, what do I do about HA pairs? What do I do about this? What do I do about that? It's literally deploy a new VPX, which is a virtual appliance in our VMware environment, stand one of these up, plug it into the route reflector, and it grabs its configuration and starts passing traffic exactly like the rest of the ADCs, only we've got that unit of capacity more now. So that's stuff like SSL transactions, things like that we can now scale up horizontally in this infrastructure. Let's see, what else? I think that's about it for that one. Yeah, and then this is a real quick, we hit on a lot of these points already, but we were, when we knew we were going to be bringing Kubernetes into the data center, when we were starting this kind of journey down sort of re-architecting what we're doing in the data center, we had to make a decision on what we're going to do for proxy, right? And of course, there's tons of open source stuff. There's tons of other kind of commercial options out there. And we ended up going with Citrix for this, for all these factors. Like I mentioned, it had all the features. Oh, the first thing I guess I want to say is that working with the Citrix team, we didn't hear a lot of no, try this instead sort of answers. It was a lot of, yes, we do that. Here's how you do it. And so we were able to kind of come to Citrix with the dream of, this is how we want our infrastructure to operate. We want these sort of features in the infrastructure. We want it to behave this way, and we were able to work really collaboratively with the team and come up with a architecture that met those needs. So it's with all these other points aside, that was probably the biggest decision factor for us. Was it just worked basically. And to Lance's point earlier, the tight integration with Kubernetes, not a whole lot of actually no custom objects. It was really just plug it in. Deploy it just like you would any other load balancer in AWS or Oracle or whoever the provider is. It just worked. So it made it really easy to bring the data center kind of up to what we're doing in the cloud. So,
nice.
So anyway, yeah, those are the decision factors. That's kind of what we're doing in the data center. With that, I'll hand it back to you, Lance.
All right. So what are, if I could jump into a, Klingon bird of prey and fling around the sun and come back and go back to myself 5 years ago or 4 years ago, whenever we started this, these are some of the things I thought of that I would shake myself and make sure I paid attention to it more. So, number one, choose your battles. That's why we started in the cloud. We also said, let's make it as simple as possible while we learn the complexity of operating Kubernetes at scale. And so we started with stateless microservices. We also, had a framework that would scaffold up a lot of stuff for the teams, which was great. And so that kind of ties into number two is alignment with the teams. We had a really good working operation with the development team that was setting the standard for how microservices were going to be designed and crafted at 8x8. And I can't stress that enough. Like that should really be your best friend at the company. So that was huge. So the other thing is we wanted to make everyone autonomous, whether it was operations working on the health of the worker nodes or the hardware, or the development teams getting their services up and running within Kubernetes. That really allowed us to Kubernetes really allowed us to kind of really truly get to that point. And so before we went cloud first, so that like I said, the way I like to put it is the environmental personalities Every environment, it grows organically. And since, we've been around for 25 years, we've got a lot of organic growth. So we didn't want to, while we were understanding and learning Kubernetes, have any type of idiosyncrasy from a personality of an environment to affect our learning. And so, the cloud is uniform. It was 100% automatable from the beginning. And so we it helped us dodge that. Number 5 is an interesting one that Mike and I can laugh about now, but it's really easy out of the gate. Kubernetes doesn't do a whole lot to protect your nodes when it launches stuff, so it's pretty important. You can tune the kubelets so that when they launch stuff, when they start up, they reserve resources for the operating system. And then from a logical standpoint within the namespaces, you've got to put down limit resource objects so that if the deployments don't limit themselves, then at least you have some sane defaults, because if it's 0, then that means when it instantiates the container, it has that one container can have 100% of all resources available, memory or CPU. So you gotta, we early on just watched deployments crush clusters. Like it would just hit one node, bring it down, go to the next node, bring it down, because there was just no limitations.
If I can throw out there also, this is something that you can actually test before you go into production, right? So there's the limits in place. There's a lot of great resources out there, on GitHub. Even the Kubernetes has the resource consumer pod that can just start to eat up resources in the cluster, just so you can test things like auto scaling, limits, things like that. So it's totally testable. It's just one of those things that we make the assumption that it's there, and we watch clusters kind of fall apart. So yeah. Anyways, I'll let you keep going.
And Lance, out of these 5, which ones are the easiest one, and which one the most difficult one to do?
Ooh, that's a good question. I would say the hardest ones would honestly, it's cultural shifts, right? That's technology is rarely the hardest part of it, right? So ensuring that you have the right alignment, you can get lucky with that. I think we were pretty fortunate. Having the weight to choose to be able to say, hey, we're going to do everything in the cloud first, like making those decisions, that could be hard. It depends on the organization, really. Yeah.
Thank you.
And to kind of wrap up, so number 6, embrace service meshes earlier. Like when we first started on the journey to get up and running and get production quality Kubernetes, the learning curve we felt was daunting. So any other additional layer of complexity we shied away from, and in retrospect, I kind of regret that a little bit, because now I kind of feel like we have a poor man's service mesh, not a true service mesh. So and you get a lot of stuff out of it, telemetry, much better security, and you can connect disparate clusters much easier than the way we're doing it now. And one of the other use cases that came up is like our framework for hosting and managing services is big enough now that it's a challenge to get it onto a laptop. So a development environment would be a lot easier if my laptop actually connected to that cluster over service mesh, and the core framework was running on the bigger cluster, but my service was just the only thing running on my laptop would be a good use case as well. Security, everyone in the world wants kubectl, but it's literally God mode sometimes, depending on how you hand it out. So you got to be careful with that. Helm has been great. It's like Yum for your microservices. It takes care of all the dependencies and when you need to deploy what, and tells you whether or not it was safe or not, and has a whole life cycle that you can hook into and stuff. Along the lines with the service mesh, decide whether or not you're going to do ingress versus services earlier. And I would strongly encourage ingress, because if you just do services are simpler, like most development environment deployments, it's a simpler object to understand. In Kubernetes, you just expose something. It looks definition just like a load balancer. So it's easy to go that route first, but every single one of those that then needs public access will turn into a distinct chargeable object in the cloud. So it will cost you more money unless you, versus doing a true ingress and letting it kind of do path-based decisions on the back end. If you don't go for something early on, then most developers, if they don't have a tool or can't find the tool to solve their problem, then they'll write it, right? So then you might get into a custom ingress that would be challenging to retrofit or fix later. And then the last two are just, regardless of Kubernetes, it's kind of common sense, but it makes it much more prevalent when you have kind of an ephemeral environment like containers. You got to get your logging off. You got to get your metrics off. The framework that the team put together took care of the formatting for everyone. So no matter what the service is now, it's much easier to get the telemetry out of the logs that you can. So those were amazing. So, and that's it. Those are our recommendations and how we've approached the DevOps three-body problem.
Mike and Lance, what advice you have to select the right ADC, application delivery controller, or a proxy, or a load balancer, whatever we call it, there are multiple names. What are the things to consider when you're migrating from monoliths to microservices?
Mike, you want to take that one?
I can start maybe. I would say that first, maybe more on the application side and this is something that I think goes for Kubernetes, non-Kubernetes, whatever it is. I think the first thing is don't make the load balancer part of your application, right? Like don't bury yourself in features, things like that. Load balancers, proxies, whatever you want to call them, are simple. Keep them that way. Don't tie yourself to a specific load balancer implementation. We're still dealing with a little bit of that at 8x8, but the vast majority of our microservices, we're smart about that, and it made it really easy to move this into AWS, move it into on-prem.
That's a good point. Putting business logic into the rules within a load balancer.
Yeah, bad idea.
I would never recommend that. It just hides it from people that eventually have to come along, and all they have access to is a source code, and they don't know that there's logic somewhere else. So yeah, it's a good point.
Exactly. And then you've got handoffs that don't need to be there between different teams and all that sort of stuff. It's a mess. But for us, I can tell you part of the decision was also we wanted to have a very kind of fluid and flexible environment on-prem. And so for us, having a virtual appliance that performed like a bare metal appliance, it was really key for us. And that the VPX really did it. It's the exact same code base as the bare metal appliance, and it works perfectly in our infrastructure. The tight integration with Kubernetes, you don't want something with a whole bunch of custom, objects and things like that you have to deal with that may be dramatically different from something you're doing in the cloud. And I guess I'm speaking more on-prem, but those are the ones I can think of off the top of my head.
And how important is operational consistency for load balancers for monoliths and microservices? Do you see the two different load balancer for each of the environment, or did you consider having a same vendor, same type of load balancer for microservices and monoliths for operational consistency perspective?
It helps to have, so we have, 8x8's a big company. We've grown through acquisitions, things like that. So we have a lot of different groups sort of operating autonomously, and we're really pulling that into kind of a common framework, a kind of common operation. So I think it helps to have all these different teams speaking the same language, when we're talking about sort of bringing this into one kind of common proxy vendor, so to speak. So that's helpful. And also, it really helps. I think this goes without saying, across teams, it's really easy to share experiences, share kind of the gotchas, the things that work, the things that don't work, when we're all sort of speaking that same technology language, when we're all speaking the same language in terms of, what are the intricacies, what are the nomenclatures, and, the naming, and what, all those things that go with, across vendors, they like to call things different things. Mm-hmm. And everyone's speaking the same language. It's really helpful, actually.
And how many approximately microservices you have currently? Not a firm number, but the range.
We're over 200 or 300 now, I think. I mean, it's one of the most satisfying things actually was we had that honeycomb grid on a big screen when we first kind of stood it up, and you know, for weeks it just had like a set number of octagons, and it kind of got boring, and then all of a sudden every single day it would get bigger and bigger, and the octagons would get smaller and smaller, and no one came to us, no one asked us about it. The framework just totally worked. It got people going. They were able to get all the way from committing code all the way to it running somewhere and didn't have to talk to anybody. And that was when we saw that honeycomb get bigger and bigger, it was really, really satisfying.
I also see a question from the audience that, do you have Kubernetes services spread across multiple clusters on-prem and cloud?
Yeah, I was trying to type the answer as well, but like, yeah, so we use a cloud load balancer in front of multiple clusters, and our ingress front door uses the native Kubernetes service discovery to find the service locally. Like once it hits the front door, it uses a path to decide, okay, is my service located locally? And if not, it has a fallback cluster that it can automatically proxy to. So that really helps us move from one cluster to another. We can stand up a cluster right next to it. You know, we can start slowly, you know, percentage-wise shifting traffic to it. And if a team hasn't moved over there yet, the proxy will help them by just redirecting it over to the fallback cluster. So that's where I kind of call it our poor man's service mesh.
Thank you. Any other questions from the audience?
Yes, please ask your questions in the Q&A tab.
I know everyone's wondering, this isn't my backyard.
So I don't know if you guys already answered this one, but do you have Kubernetes services spread across multiple cluster on-prem cloud?
Yeah, so that's one of the reasons why we went with a cloud deployed load balancer first, so that because we knew we would be bringing stuff on-prem, but we wanted the front door to look exactly the same. So yeah, we've got it spread across multiple regions in cloud providers, and we have the stuff on-prem. All that goes to the same. For the first front door is that load balancer, and then it can route traffic to any of them.
I think we have another question from Ricardo. What CI/CD techniques you adopted to empower engineers to manage their microservices? Something like GitOps paradigm?
Great question.
Sure. Yeah. So we embraced Helm. The framework scaffolds up the software components for the service, including a pipeline definition for them and their Helm chart. And so most of the teams, their Helm chart is no more complicated than a single line, and they just call a template that's part of a common Helm chart that that framework team has defined. And so with a few value additions in their values, then it drives that whole template and renders whatever they need, a deployment object, a full service, or whatnot. And so most of our stuff was based on Jenkins 2.0 for kind of shuffling stuff along. We did our own Travis CI type layer on top of the Jenkins 2.0 pipeline, so that the teams just needed a modicum of YAML to push through different stages. Yeah, so it ended up creating a container and a Helm chart as the artifact results, essentially.
And maybe to expand on what you're saying there, Lance, a little bit, is that that framework, provides all the monitoring hooks, the logging, all the infrastructure pieces too.
So that framework team, pulled in an APM. So we started using New Relic, and so all the clusters are instrumented with New Relic. And so the log aggregation sent everything to a central log location, so the developers could see their logs, they could see the metrics from the APM, and the APM is also tied in with monitoring Kubernetes itself. But yeah.
So we have a follow-up question. Does it work with AR64?
And is that with respect to like building a container specific to a CPU architecture, I guess? Is that the question? Right now, I don't think we are architecture specific to our containers. All of our operating systems are Linux based, and our code base is like 90% Java. So the developers are so abstracted from it. I don't think there's anything hardware specific.
Wonderful. And if you want to try Citrix load balancers or ADCs, we offer in physical, virtual, container, as well as in the sidecar. And that is also, you can integrate with Istio. You can integrate with many of the CNCF open source projects. We also integrate with Prometheus, Grafana, Spinnaker, Helm. There is a huge long list, and you can find more deployment code examples, the trial versions of the products at github.com/Citrix, and you will find wealth of information about it. If you are still considering that what is the right architecture for you to pick and choose from simple two-tier ingress to service mesh, or if you like service mesh but like less complexity, then there is also architecture service mesh like. We compared 4 different architectures in a previous webinar. So if you look at the previous webinar, that how to choose the right architecture for application delivery, you will find those webinar and also the white papers associated with that.
It's a question for you, I think, Pankash.
Yes, the question is that are Citrix load balancer easy to use, and also are there any free versions to get it started? One of the primary driver for Citrix load balancer is to make it very simple for our customers to use. So they are very easy. You have a centralized management platform like Citrix ADM, which allows you to manage and control and all your load balancers. You can deploy load balancers in various form factors as on-prem or in physical or virtual or as a bare metal. They are also available in all the major public cloud providers like AWS, GCP, as well as in Azure. And the beauty is that all of them have the same same code base, so you have a feature functionality associated with that. Also, you have it in the container, so if you want to use it for east-west traffic, if you want to use it for as a sidecar for service mesh, so all those options are available. For the next question about getting the free version, you can find those free versions at Citrix website, and also many examples of that at the GitHub.
And I can probably expand on the ease of use side of things as well. You know, I prior to 8x8, I hadn't really touched a NetScaler for, I don't even know how long. It's been many years. And so a lot has changed in the more recent versions. And so jumping back into that after having kind of been more focused on things like, ELBs and, more of the cloud stuff for several years, it was really easy to kind of jump back in and feel my way around. But I think the most important kind of point, this being more of a Kubernetes focused webinar, is really at the end of the day, that configuration. I mean, we don't look at the UI or the command line for the NetScalers. Once we get them initially set up, which means basically peering those with our route reflectors and plugging those into the Kubernetes cluster, which by the way is trivial. There's an agent that runs. It's an agent that runs within Kubernetes that manages those. But once you get that initial integration done with your network and with Kubernetes, the rest of it is driven purely through the Kubernetes API. So it's really cool. You can actually say, deploy my service, service type load balancer, let's say, for example, and if you wanted to, you can click into the UI and see all those objects built out in the ADC to match kind of what you defined in your deployment. And to kind of go a little bit further with the ease of use, there's a ton of great examples for Kubernetes out on GitHub. Everything from managing SSL certs, whitelist, blacklists, all kinds of stuff out there. So I mean, that's all stuff that you can drive through Kubernetes to configure your ADC. So I mean, in terms of ease of use, it's almost insignificant. It just works.
Back to you for closing.
Awesome. Well, thanks guys for an awesome presentation. And I want to thank everybody for joining us today as well. The webinar slides and recordings will be up later today, and we look forward to seeing everybody at a future CNCF webinar. Have a great day.
Thank you.
Thanks for having us.